So we're going to have a go at 18b now. We've got this metal strip here. It's being pulled from end to end. It's given us dimensions. We've got 15 centimetres long, it's 1.2 centimetres wide, and 0.018 millimetres in thickness. I suppose the first thing we have to point out is they're trying to be sneaky and tricky because they've given us this one in millimetres, this one in centimetres, and this one in centimetres, so we're not going to let that catch us out and give us a power of 10 error. Right, we've given some other information. The breaking force of the strip is 16 newtons, and the Young modulus of the metal is 7.1 times 10 to the 10 pascals. The first part, so we're going to calculate the extension of the strip when it breaks, and we've got to then give an assumption in our calculation. Okay, so I'm going to do this first. Well, we're after the extension, so I'm going to realise that I know that the strain is equal to the extension over the length. Therefore, the extension is going to equal the strain multiplied by the original length, and I know the original length, but I don't know the strain, so I need to work out something else that will let me get to the strain. And I know that the Young modulus is equal to the stress over the strain, and that's fine because I'm given the Young modulus, but I don't know the stress, so I'm going to need a third equation, which is going to say that my stress is equal to the force over the cross-sectional area, and I'm given the force, and I can work out the cross-sectional area, that I've got my width and I've got my thickness. So let's work out the stress. So that's going to equal 16 divided by 1.2, and I'm going to put it into metres because we've got different units going on. So minus 2, multiply that by the thickness, 0.018 times 10 to the minus 3. Let's make that a little bit bigger, and that's going to give me stress of 7.41 times 10 to the 7 pascals. Right, now I know the stress. I can now put that into the next equation up. So that's going to tell me, well, I'm after the strain this time, so the strain is going to equal the stress over the Young modulus. So that's going to be 7.41 times 10 to the 7 divided by the Young modulus, which is given as 7.1 times 10 to the 10 pascals. Put those numbers into my calculator and it would come out as being 1.04 times 10 to the minus 3. And now that I know my strain, I can put that into my final formula up the top, working backwards. So put that into here, and that will tell me when my extension is going to equal 1.04 times 10 to the minus 3. Multiply that by my original length, which is 15 centimetres, not forgetting to put that into metres, like I have done with everything else, and then that will come out as an answer of 1.6 times 10 to the minus 4 metres. The only last thing I've got to do is I've got to state an assumption made in my calculation, and the thing is I've assumed here is, because I'm using the Young modulus all the way through, and that tells me that the stress is proportional to the strain, so my assumption would be that it is obeying Hooke's law. Sorry, I didn't have the space down below where I should have written it in.